All right, so you want to know how to get to the derivative of any function that you lay your eyes on. So today we'll be going over one of the derivative rules, which is the power rule. Now, the power rule states that a function f(x) equal to, let's say, x of n, the derivative, so f prime of x, will be equal to n x to the n minus 1. Now, if you're not good with the general form, let's take it up with an example. So let's say we have x to the 3. Now, according to this, our n value would be 3. So, oh, sorry, let me write f of x first. Okay? So our n value would be 3. Now, according to the power rule, what we want to do is bring n down as a coefficient of x and then subtract 1 as the new power. So what that is going to give us is f prime of x is equal to 3x squared. Okay, so we brought the 3 down as the new, so we multiplied it by 3, and then we subtracted 3 minus 1 to get 2. Okay, so that's a very simple explanation on the power rule. So now let's try a pretty much the same concept, but x to the 5 this time. So if we have x to the 5 and we want to derive it, we need to bring n down, so it'd be 5x, and then 5 minus 1 would be 4. So the derivative of x to the power 5 is 5x to the power 4. All right, and also, if you ever have a function that's just like 9x, so this would be 9x to the 1, you don't write the 1. So you bring over the 1, so 1 times 9 is still 9, but now it's x to the 0. So x to the 0 is nothing, so now the answer is just 9, all right? That brings us to our next topic. If you just have 9, let's say, the derivative of 9 is 0. Okay? It's nothing. The derivative of 5 is also 0. The derivative of 4x is just 4. So if you've if your unknown variable is to the power of 1, you just get rid of that whole variable and just leave the coefficient in front. All right? So even 909x, the derivative is just 909, all right? The derivative of 1 is 0. A question that's a little step up. So 7x to the power of 4. Now you may be thinking, there's a 7 here. So what do I do? So pretty much it's the same thing. So you have 7x and you have 4. Okay? You bring the 4 down. So now it's 4 times 7x. And then you subtract 1, which is 3. So that gives you 4 times 7, which is 28. 28x cubed. Boom. Now you just did it with a constant in front, okay? So pretty much it's the same with or without a constant. Or sorry, when the constant is not 1. You literally just multiply by the constant as well. So yeah. Now we're getting on to the next question, which is f of x is equal to minus 2x to the 6. So we just went over this, but now we have a negative. So maybe take a second to try it for yourself. But the derivative, so f prime of x, is equal to 6 times negative 2. I'll put that in brackets. X to the power of 6 minus 1. So 6 times negative 2 would be negative 12, and then x to the 5. Bang. Now you know how to derive with the power rule for negative coefficients as well. So now let's take it up a notch again. All right. So now we have f of x is equal to 5x to the negative 3. So now we have a negative exponent. All right. Pretty much the same thing applies here. Bring down the 3, subtract 1. So it would be negative 15, and then x, and then careful here, it's negative 3 minus 1. So it wouldn't be negative 2, it would be negative 4. All right, so always pay attention to the symbol if it's positive or negative. And then now for the next question, we have 1 over 2 x to the 10. All right, so then it just becomes 10 times 1 over 2 x to the 10 minus 1. Okay, now 10 times a half would be 5. So 5x, and then 10 minus 1, 9. Okay, so the derivative of this one is 5x to the 9. Now let's try a square root, all right? So f of x is equal to root of x. Now you're thinking, how do I even derive this? There's no exponent here, or there's nothing. But remember, root x, or square root of x, can be written as x to the power of 1 over 2. All right? So these two terms are equal to each other. So now that we have it like this, you can simply write 1 over 2, because we're bringing down the 1 over 2, x, and then 1 over 2 minus 1 would be minus 1 over 2. So that's the derivative of root x. Now, if your teacher's okay with it like this, you can leave it like this. But to simplify it, all you want to do, since we have a negative here, is you can just rewrite it as 1 over 2 root x. Because x to the 1 over 2 would be root x. X to the negative 1 over 2 is still root x, but you just put it in the denominator with a 2. All right? So this is the simplified version, but if your teacher doesn't care, you can leave it like that if you want. On to another one. So 1 over x squared. Now, maybe take a second to try to solve this for yourself using what we just learned with the square root. But pretty much, you can rewrite this as x to the negative 2. All right, so these two terms are equal. Okay, so if you ever have like something to an exponent in the denominator, you can always bring it to the numerator by just making the exponent negative. All right, so now that we have this, we can write negative 2 x to the negative 3. All right, because we bring down the 2, and then 2 minus 1 is negative 2 minus 1. Always pay attention to your symbols. Would be negative 3. So that's the derivative. Now we're getting into what's called the sum rule and the difference rule. So that states that if f of x is equal to some g of x plus or minus h of x. Now, the plus or minus just symbolizes that it could be either plus hx or just minus hx. So just one of them. So don't get too scared by that symbol. So the derivative would be g prime of x plus or minus h prime of x. All right. So when you have multiple terms, you just apply this rule. Okay. So gx just becomes g prime, hx becomes h prime, and you keep whatever symbol was in between them. So if we have x to the 2 minus x to the 3, then the rule states that it would just be 2x minus 3x squared. All right, so you keep the symbol. So the plus or minus literally just means whatever symbol's there, either plus or minus. Keep it there, and you pretty much get the derivative of each term separately. And that's the sum/difference rule. So it's technically the sum rule when it's addition, and the difference rule when it's subtraction. But it's the same thing, just with different symbols. Now we're getting into multiple terms. Okay, so 4x cubed minus 5 over x, and then plus root x. So you should now be able to solve this based on all the questions that I just went over with previously. So take a second to do it by yourself, and when you're ready, let's do it. Okay, so you can rewrite this as, since like like I don't like it when it looks like that, so you can rewrite it as 4x cubed minus 5 to the x minus 1. Remember, when you have something in the denominator, so x, and it's to the power of 1, you can always bring it up and just make the exponent negative. So that's what we did. So now it's 5x and negative 1, and then plus x to the 1 over 2. Okay, so now this looks maybe still a little frightening, but all you have to do is break it down into its 3 parts. So you have 4x cubed minus 5x to the negative 1, and then root x. Okay, so the derivative of 4x cubed would be 12x squared, right? And then the derivative of minus 5x minus 1. So if you bring down the negative 1, there's 2 negatives there. So it would be 5x to the negative 2, and it's positive. All right. And then root x, we already talked about this. You bring down the 1/2. So now it's 1/2 x to the negative half. And in simple terms, or simplified, you can write as 1 over 2 root x. Okay? Boom. Now you know how to factor something with multiple terms. All right? Now, for the final question of the video, it's similar to this one. There's multiple terms. We have 3 over 2 x to the 5 over 2. All right, and then minus 7x to the negative 4 plus 9x. All right, try it by yourself, but here's how you do it. Okay, so you have 3 over 2 x to the 5 over 2. So you bring down the 5 over 2. So 3 over 2 times 5 over 2 would be 15 over 4. All right, so we have 15 over 4 x, and then subtract 1 here, so we'd be subtracting 2 over 2. Okay, so 5 minus 2 is 3, so x to the 3 over 2, right? Now we have our second term, so bring that down. Bring the 4 over, and it's negative already, so we have 7 times 4, which is 28, so plus 28, because we have 2 negatives, plus 28x to the negative 5. Negative 4 minus 1 is negative 5. Now we have 9x, okay? 9x, so what we're going to do, so you can see 9x is pretty much 9x to the 1, all right? You don't include the 1, but it's there. So when you bring this down, 1 times 9 is still 9. But now 1 minus 0 is 0. So now we have x to the 0. So what that means is you just don't write the x anymore. There's no more x. So the final answer is this. So you can simplify it if you want as 15 over 4 x times root x because x to the 3 over 2 is just, so it's x to the 1 right here. So there's a 1. X to the 1 times x to the 1 over 2. And when you're multiplying, you just add the exponents. So 1 plus 1 over 2 would be 3 over 2. Okay? And then you have a negative here with the exponent. So you can literally just do, as I said earlier, 28 over x to the 5. Because when you have a negative, you can just bring it down to the denominator and make it positive, and vice versa. All right? And then 9 stays the same. All right? So hopefully you learned a thing or two. You got some good practice in. But now you're strong with the power rule. So good luck out there.